Hello again, everybody. Welcome to a new screencast lecture. Tonight's topic is sedimentary clastic rocks. Let's get started. First of all, let's kind of do a little quick review. There are three different rock types, and they are, well, igneous, sedimentary, and metamorphic. And of those three rock types, which is the most common throughout the entire world? So this includes on the Earth's surface and below the Earth's surface. Well, the most common rock type in this case is igneous rock, and they're the most common, but most of the rocks that are igneous rocks are going to be found below the Earth's surface, so we generally don't see at least as many of them as you would expect since it's the most common rock type. These new igneous rocks, they're being formed all the time. Whenever magma or lava cools well enough to solidify, you're going to form new igneous rock. However, at the surface, about 3/4 of the rocks that are exposed at the surface are sedimentary rock. Therefore, if you were just to pick up a random rock that's laying on the ground, there is a better chance that it is sedimentary rock than either igneous or metamorphic rock. Let's focus on sedimentary rock today. So how is sedimentary rock formed? Well, sedimentary rock can be formed in three general ways, but before we get to that, we need to have a little bit of background, a little bit of common vocabulary. So if you think about igneous rock, there are two types of igneous rock. Those two types are, go ahead and fill in the blanks. Igneous rock can be blank igneous rock or blank igneous rock. Well, it can be intrusive or extrusive igneous rock. So there's two different types of igneous rock. And metamorphic rock, there are two different types of metamorphic rock that you may or may not know. Those two types of rock, metamorphic rock can be either foliated or non-foliated metamorphic rock. So there are two classifications of igneous, there's two classifications of metamorphic rock. Sedimentary rock, however, has three classifications, and those classifications are determined by how the sedimentary rock itself is formed. The first type of rock is called clastic sedimentary rock, and clastic sedimentary rock is formed by pressing little bits of rock together, and those little bits of rock can be called clasts, or they can be called sediments. I prefer to call them sediments. Before we get into the details of classic rock formation, let's learn a few vocabulary terms. And for example, like sediments. The term sediments would be small pieces of rock and mineral. Sediments are named by how large they are. And so here you see a chart going anywhere, in this case, from a large size that would be considered pebbles down to the tiniest size, which would be clay. Good way to think of it, I think, is if you can't see the sediments at all, even with a magnifying glass, go with clay. If you can't see it with your naked eye, but with a magnifying glass, maybe you can see it, maybe go with silt. And if you can see it, but they're small, and most people are familiar with sand, we call that sand. And then pretty much anything bigger than sand, we'll go with gravel or pebbles. Here's a little chart showing you the three types, or the four types. These are the four types I'm going to expect you to know: gravel, sand, silt, and clay. How are these sediments made? The way that the sediments are made is called weathering, and weathering is destructive forces that change rocks into smaller pieces. And again, we can call those smaller pieces sediments or even clasts. Some ways of weathering can include temperature changes, water smashing into rocks, wind picking up fine bits of sand and rock and smashing it into other rocks. I like to think of weathering as a rock being smashed with a hammer. So when you take a hammer and you smash a rock, you're going to get tiny little pieces from doing that. That's weathering. Some weathering examples, let's think about temperature change. So temperature change is primarily done by water, and water will get in the cracks like you see here, and when water freezes, it expands, and it's going to make that crack even bigger and even break the rock. This is called frost wedging, so you have water getting into cracks, freezing, breaking apart the rocks, and this process happens over and over and over again until the rock is broken into many, many pieces. Wind damage. Here's a photo showing wind damage. You can see these pock marks on it, these holes on the side. Here you see a rock formation with the bottom part worn down more than the top part. And this is going to occur because wind is going to pick up little pieces of rock, like little pieces of sand, and that sand is going to smash into the rock, and that's going to break the rock down. Now the bottom part is going to be worn down more than the top part because there's going to be more sand lower towards the ground. The wind is strong and it can pick up sand, but the sand does have mass, the sand does have density, and it's going to be more prevalent down lower towards the ground than higher up. So the higher part of the rock is not going to be as wind damaged as the lower part of the rock. Here you see kind of the same effects. You'll see all kinds of neat little features due to this effect. Here's a clip.
The heat is on for those Boy Scout leaders who could face felony charges for a videotape rocketing around the country. Men causing trouble inside a state park in Utah, destroying a sacred rock formation millions of years old, and then high-fiving one another. ABC's Aditi Roy tracked down the men to ask what they have to say for themselves tonight.
They evoke mystery and wonder, these spectacular Utah rock formations known as goblins. This goblin has balanced here for 20 million years.
Wiggle it just a little bit.
It took Glenn Taylor fewer than 20 seconds to knock it over.
Ah! Yeah!
Taylor, his son, and a pal, all Boy Scout leaders, posted the video on YouTube, and their destruction of the natural wonder triggered a firestorm. The Boy Scout organization is furious, saying the men violated the Scouts' leave no trace policy of respecting nature. A criminal investigation is underway. So today we track Glenn Taylor down at home to ask him the one question on everyone's mind.
Some people might ask, what were you thinking?
Safety.
Taylor says the rock was loose, that he was worried it would topple over and hurt someone, so he decided to topple it himself.
It's all about saving lives here at Goblin Valley. Saving lives, that's what we're about.
Utah Park Ranger Jeff Rasmussen doesn't buy it.
I'm not aware of any of these rock formations ever toppling over on anybody. I've worked for Utah State Parks for 22 years. I've never heard of anything. This took millions of years to form. It's a one-of-a-kind natural feature.
Ah!
Tonight it's clear Taylor has some regrets.
The Boy Scouts didn't teach me to do this way. Would I do it again with a ranger standing there? Yes. That's what we should have done.
Still, in this battle of man versus nature, nature lost. Aditi Roy, ABC News, Highland, Utah.
Water damage. Water damage is going to give you some similar effects as wind damage. Water is going to be more effective. You also get more of a smoother look normally. So you can see these river rocks, that you get the nice smooth appearance of these rocks. You see how over time the water is going to smooth out its edges, the hard, sharp edges. After weathering occurs, you're going to have erosion. Erosion is when the parts that were broken off during weathering get taken away. So it's a physical removal of rock particles, and that's usually done by wind and water. Here you see some photos of erosion. You see this poor guy, his backyard is vanishing. That's not a good situation you want to be.
A group of hikers in Cornwall got a first-hand look at coastal erosion in its most dramatic form.
There it goes.
This cliff collapse at Dead Man's Cove is the second to be reported on the same stretch of coast in recent weeks. It's believed climate change is the main cause of this type of erosion, as it's causing sea levels to rise.
Some more erosion photos.
Fast-moving floodwaters, leaving a path of destruction in Woodland Park.
It's 6-foot hole right there.
Floods wiping out wood and concrete bridges. Down into Green Mountain Falls, visitors heard the rushing water as it pooled over their campsites.
The water was way up. Just up here on the bank where the water should never be was already up to people's ankles.
That's why she decided to forego shoes while they moved tents away from the creek as it grew into this.
After the raining stopped, all of this was underwater, and this is what was left. It went down pretty quickly, but this is what was left whenever I came out of the tent.
Now that the water has...
And we talked about that weathering is the breaking down of rocks into smaller pieces. Erosion is the removal of rocks. Here we can see this in action. Deposition is when that weathered rock that got moved, that got eroded, finally gets dropped off in a new location. So deposition is when the eroded rocks and minerals are left in a new location. Here we have a stream. The stream is going to be going this direction, and it smashes into this side of the wall, and it is going to do what to this side of the stream? Well, it is going to cause erosion, and that erosion is going to make sediments, and those sediments are going to be dumped off here, because on this side the river is going to be going more slowly here and here than it is here and here. The river here is going to be deeper. It's going to smash into this side of the wall. It's going to smash into this side of the wall here. It's going to be more shallow here, and it's going to be traveling more slowly here, and it's going to do deposition in this location and this location. When a river enters an ocean or lake, the river is going to slow down. When the river slows down, it's going to dump a lot of these sediments in that area, and it's going to form what's called a delta. So at the end of rivers, you're often going to see what's called a delta. We're finally ready to discuss the formation of clastic sedimentary rock. So wow, that was quite a bit. So we went over weathering, erosion, deposition, and now we're finally ready to figure out how that clastic sedimentary rock is formed. First of all, forming clastic sedimentary rock. Step 1, existing rocks are weathered and eroded. Now you see why we have to talk about weathering and erosion. So here's a big rock. It gets weathered and erosion and makes tiny, smaller pieces of sediment. Nice little GIF there. Not too bad. All right, we had existing rocks that are weathered and eroded. Now these sediments are going to be pressed or compacted, and so here's the sediments. They go down into the river. They are going to be compressed here, and then they're going to be cemented together. So you're going to have the pieces of sediment. There's going to be empty spaces in between where there's no sediments, and then other material can get in between what's called the pore space, and then that material can harden and cement and hold that rock together. So here we have a whole bunch of loose sediments. Eventually that can be compressed and cemented. That's kind of the key phrase. Compressed and cemented to form new sedimentary rock. So compaction is when the sediments get pressed or squished together. Here you see some compaction of material by this tool. So the loose, non-compacted sediments will get compacted. They'll take up less space, but they still have some empty spaces, pore space available, where water, air, and other smaller materials can get in between the particles. Now this is interesting. If you take a layer cake, and we've actually done this, where you take a layer cake, you cook 3 equal layers, and then you put them together and frost them, the one on the bottom gets squished more than the one on the top. The reason why is that this one has the most weight on top of it, so it's going to get compressed and compacted. This is the same amount of cake here as it is here. However, there's a lot more empty space, air bubbles than here because it's been squished. This part down here has been squished and compacted, and you can see it here again. So here's the bottom layer. This red arrow is the same size as this red arrow here. So you can see this top layer was compressed to form this layer down here. Cementation, this is the gluing together of those compacted sediments. Here you can see in this drawing, you can see the larger pieces of sediment, and then you can see in between, it looks like some mortar. That's that glue, that's that cementation that's going to hold all these little chunks of rock together to form a new rock. Some examples of clastic sedimentary rock. Here's shale. Shale is the most abundant sedimentary rock. You may have heard of oil shale. This is a shale rock that is somewhat flammable. You can get oil from it, which can then be used to make gasoline. There's a lot of it in Canada and some other places in North America. Sandstone is a clastic sedimentary rock. Sandstone is generally laid out in layers. Here I have a sample of sandstone. You can see that It kind of is in layers. It's a little bit darker here, it's a little bit lighter here, and it even feels a little bit gritty from the sand. Here's a clip.
Sandstone is formed from deposits of sand which are laid down horizontally at the surface. In this case, these were probably laid down either in a channel or perhaps along a beach. What happens then is that through time the sand becomes buried, and as it's buried it's compressed by the weight of overlying sediments deposited on top of it, and that compression squeezes out some of the pore space between the grains and puts them closer together. And then water percolating through the sand, groundwater, has minerals dissolved in it, and sometimes those minerals can come out of solution. They can precipitate between the grains to create a natural cement which helps to hold this rock together. And so this is what we would call a clastic sedimentary rock. It's a rock that's made of particles of small bits of rock, small sand grains in this case, cemented together by natural cements. We get this rock sandstone.
Here's breccia. You can see the larger sediments, the larger clasts, and then the cementation is very, very easy to see. It's neat rock. Conglomerate, similar to breccia. Note the differences in sediment size. So here you have very, very small sand-sized sediments. Here you have some more gravel-sized sediments. Here you see shale and mudstone. It has very, very tiny sediments, and you would consider that either clay or silt. You cannot see the individual sediments or the individual clasts without a magnifying glass. And here is sandstone, which we already looked at. It kind of looks like little pieces of sand squeezed together. That would be sand-sized sediment. And then a gravel-sized sediment, these larger chunks like a breccia and conglomerate. Here's a clip.
Sedimentary rocks are formed when we break down other rocks like igneous rocks, sedimentary rocks, or metamorphic rocks into pieces through weathering by wind and water. As these pieces break down and roll and tumble down the rivers, they go from big pieces to smaller pieces and smaller and smaller and smaller until the very end what we have is practically a powder. In this case we've got our grapes, which would be our gravels or our pebbles, and they're over 2 millimeters in diameter. This is a very coarse sand, up to 2 millimeters in diameter. And then we've got our very, very, very fine sediments. In this case it's flour that we're using to show this. Strata could look like this, like our cereal treats here that have our candies, and our candies might represent things like fossils. This is my trail mix, and this stuff could be forming a rock that looks something like this, something like our granola bar. So we have many different possible mixtures of grains based on what types of rocks were originally exposed and weathered and eroded, and how far those grains have been transported, and how small and weathered each of those grains has become. And not only that, but what were the conditions like in the lake or the ocean where these things were deposited. So sedimentary rocks are very critical for our understanding the process of how the earth has been eroded and how new rocks have been formed through the many, many millions of years that the rock cycle has been underway.
Well, that's all we have for you tonight. Hopefully you learned something. If you have any questions or comments, leave them down below. Hopefully you'll like this video and also subscribe if you have not subscribed. See ya!